Today we'll be talking about binomial probability. So binomial probability is an experiment. And these notes are just in with your other notes. So last couple pages. It's an experiment with a fixed number of independent trials each of which has two outcomes. Okay. There are 4 conditions to meet this. We use the acronym, the BINS, right? And when I say each one has 2 outcomes, that means a success or a failure. It's like yes or no. Success, failure, win, lose. We can't. No. All right. So what are these 4 conditions that have to be met to have a binomial probability? One is it must be binary. Binary means 2, right? Like binomial. So there's 2 choices, right? Success or failure. Those are my only 2 choices. I don't sort of get it. I either succeeded or I failed. Like I'm flipping a coin and I consider tails a success, then heads would be a failure, right? We have to get them kind of to a yes or no. The second condition is they must be independent. And that means the result of one trial does not affect any other trial. Like when we flip a coin, no matter how many times you flip tails, it doesn't affect if you get a head the next time. They're independent, right? The number of trials right, must be fixed in advance. Meaning I say I'm going to flip the coin 10 times. It's not like when you flip a coin with your friends and you win and they say, okay, best 2 out of 3. Then you win again and they say, okay, best 3 out of 5. We can't do that. We have to say in advance, we're going to flip it 10 times. We're going to flip it 30 times, and that does not change, right? Lastly, success. Okay, the probability of success must be the same on each trial. I can't say the probability of success is 0.3 for this one and 0.4 for that one. Has to be the same chance for success, okay? So what are the steps? I want to run this binomial probability experiment. What are my steps? to make sure all of this happens. One, I have to define success. Maybe rolling a 4 on the die is my success. I'm looking for 4s. Maybe flipping a coin and getting heads. Right? 2, I have to define probability. Of success. Right? I have to say the probability of getting heads is 0.5. The probability of rolling a 4 is 1/6. So we have to define what are your chances of succeeding. If I have to define succeeding, what else do I have to define? Yes. So the probability of success has the small letter p. The probability of failure is 1 minus p, right? Because if the probability of success is 0.3, then failure is 0.7, right? They have to add up to 1. Or you might see the little letter q. It's easier to write a q than 1 minus p, right? But what do p and q have to add up to? 1. We're familiar with that, right? So I have to tell you the probability of success is 0.2. The probability of failure is 0.8. I also have to define number of trials. How many times am I going to run this? How many coins am I going to flip? I'm going to flip the coin or roll the die 52 times, whatever it turns out. But remember, we cannot change our mind once we start because we don't like what's happening, right? And then we define number of successes we want out of these trials. Right? And we call that X or R. Depending on your calculator, that's X or R. In other words, I say, what's the probability that I win 4 times? Okay, so how many are we looking for? What's the probability that you can roll a 5 on the die 21 times out of 34 tosses? Okay. And it's very, very easy. We're just kind of writing the rules down. And you kind of know by common sense you would have to do those things, right? So we have to know what is a success, heads, tails, getting a king, queen, or ace out of the deck. What is a good thing? You consider yourself a winner. What's the probability of doing that? What's the probability of failure, losing the bet? How many times are we going to do this? And what do we want? How many times can I pick a queen? Or what's the probability that I'll get a queen at least 8 times when I randomly pick, right? So that's what you want. All right. So what are some examples of binomial? So these are versus are not. Sometimes we have to look at what something's not to make sure we know what it is. So let's see, I toss a coin 20 times, right? Count tails. So a success is tails. Probability would be 1/2. I know that. Probability of failure, number of trials, 20. They're independent. What would not be a binomial is if I tossed a coin until I got 20 tails. Do you see the difference? Do you see the difference between those two? Here we say we're tossing a coin 20 times. What's the probability that we get, 15 tails? Here we're saying, well, I'm just going to flip that coin till I get 20 of them. Can't do that. Another might be ask 30 people if they watch. What's a good TV show? What do people watch? Nothing? How about The Mandalorian? Right? So I asked 30 people. It's a yes or no binary question. Do you watch The Mandalorian? I get yeses or nos. Yeses are success, failures are no. What would not be binomial is ask 30 people what they watch. So if I just say, hey, what do y'all watch? I'm going to get a whole bunch of different answers. That's not binary, right? But if I say, do you watch The Mandalorian? That's yes or no. That's a success or a failure. This would have no way to have a success or a failure, right? Rolling a die. To see if I roll a 5. What would not be binomial is rolling a die until you get a 5. Does everyone see the difference in what a binomial is? Binomial probability, we have to say 5 is a success, any other number is a failure. We know the probability for dice or cards or coins. We may not know the probability for some other things, like the probability that the Rangers will beat the Blue Jays. In that case, we would have to look up what's the probability, right? Now, if you look at your calculator, but let's all find this in our calculator. I'm going to show you where our 2 buttons are. So you're going to go second vars, and you either do alpha math and go to binom, or you go alpha apps. And let me show you what you're actually doing. You can scroll down, and there's 2 choices you have: Binompdf, Binomcdf. Right? Second vars, alpha math A or alpha math. It's just the B key. Apps. You see the little A's and B's, and it's just A or B. That just pulls you down faster. You can scroll down. Okay. Binomial is if you have an equal sign. Like I say, what's the probability you're going to get exactly 4? CDF is if we have this. If we have at least or greater than or less than. So if it's exactly equal, we're a PDF. If it has a greater than symbol or a less than symbol in it, then we have to use CDF. Okay. And it's going to do how you're going to type it in. N is the number of trials, right? P is the probability of success. R is going to be the number you want. Like I say, what's the probability you get exactly 4 heads when you flip the coin 20 times, right? And we'll practice them now, and this will all make sense. Okay, here's our example, right?
Miss Coughlin, what did you say R was again? Sorry.
Oh, you're
Yeah,
good.
could you
You're
go
good.
back to that other page real quick?
Yes, absolutely. You need the top half too. Here, there you go. Did you get that half? Okay.
Thank you.
Take time and write notes to yourself. And when we do the examples, you're going to find it very easy. Now, one thing I'm going to recommend is you just write a few numbers down and you'll see what those are. If you take the time to write a couple of numbers down, it will help you decide if you're right or left. It's a very good technique. So let's look at this. A water bottle contest is giving away prizes. Under each bottle lid is either the word winner or try again. There is a 1 in 6 chance of getting a lid that says winner. 6 friends go to Tom Thumb and each buy a bottle of water. Find each of the following. Okay, if 6 friends go and they each buy a bottle of water, how many bottles of water do I have? 6. N is how many of the things do we have? What's the probability of winning a prize? 1 out of 6, right? They had to tell us that. Here, I'm going to underline 6 bottles, 1 6. If winning is a 1 in 6 chance, what's the chance of losing? Now, the old-fashioned way of doing this is to do the, well, I'm not even going to show you. I thought I typed it on there, but anyway. Right? The old-fashioned way to do this is to type it into your calculator like this. And we looked at this button in your calculator, but we're going to use Binompdf and Binompdf. So here we are. We went to Tom Thumb. Find the probability of 2 winners. That's exactly 2 winners, right? What's the probability of exactly 2 winners? Well, that would be 2, right? R equals 2. If you have an equal sign, we know that that's a what? PDF or CDF. That's a PDF. So I just say binom. And y'all have a piece of paper when you try to do your work. You're going to doodle just a little. So I put down how many bottles or how many things there are, the probability of winning, and how many I want to win. I want 2. So type that into your calculator, and out comes the answer. Go, go, go. See if you get what I got. There's a couple little things that could happen, so you need to really type these in. I should see the fingers going, flying over that keyboard. It's the A key, alpha, basically alpha A or alpha math. If you want to B, it's alpha apps. It's just the quick way to pick the letters A or B. So here's vars, second vars, and you can scroll down and you'll see Binompdf, Binompdf. This, if you don't want to scroll, you can do alpha math, which is alpha A, which will pull you down faster, or alpha apps, which is alpha B, and that will pull you down here faster. Okay, so you're going to type in a PDF because it's exactly 2. And you should get that. Did you get what I got? You probably don't. Okay, go to. You don't have commas because it's just asking you. I'm just writing down what you're typing in. So 6, 1 6, 2. And then it will put it like I wrote it. Yes, second vars. Now scroll down to A or pick alpha A. You could scroll down, just scroll down, and it'll come after the 10, or you can do alpha math, which is the A button, and it'll pull you down there faster. You don't have to scroll. Oh, the phone calculator might not do that. Yeah. No, I would put a fraction in. I put a fraction in. Okay, let me pause this and I'll come around and check your calculators real quick. Whoops. Okay, so if I want 2 or less, that means 2, 1, or 0. I now change it to a CDF because it's more than one thing, but your calculator always reads to the left, so you just type it in. Everybody make sure you got that. If you didn't, we got to fix it. We can't move on if you don't have it. Everybody have it? Right? Now we're going to change up what we're asking for. This says the probability of between 4 and 2. So I can have 2, I can have 3, I can have 4. Again, if someone told me between 78 and 80, I would just write, 74, 75, 76. Just write those numbers that you're talking about. It really helps you to do the math to see this little visual. So how am I going to do this? You've done this before. We know it's a CDF problem. You had to do this with z-scores, remember, when we were in between? So what do you think we do? Yeah, we have to do a CDF of, now that's going to read everything to the left of 4. Do we want to include 1 and 0? No. So we have to subtract off right? And you know that it's binom, right? I didn't write the binom down. So you have to subtract them because you want the middle part, but it always reads left. So you have to start with the highest number, subtract off the lower ones that are not included.
Why'd you do 1/4?
Oh, because I said 4, that's 1/6. Sorry. I was talking about the 4 and I got ahead of myself. Thank you for catching that. Because we said it's between 2 and 4. And when we put the 4 in, that's going to read from 4 all the way down to 0. And we don't want to include the 1 and the 0. So we subtract off what we don't want. This is very, very important because if you see that, these are all simple. We just want these. Is everybody okay? We got one more thing to look at, what we haven't looked at. We've looked at exact, we've looked at less than, and we've looked at between. What haven't we looked at? Greater than, right? So in your mind, it says R is greater than 4. What does that mean? 5 or 6. How do we do this? Your calculator only reads left. So what do we have to do? We have to find what this part would be and do what with it to find out what would be bigger? Subtract from 1. So we're going to say 1 minus this pink part. CDF, right? There's 6 bottles. The chance of winning is 1/6. And I don't want those. Okay? So remember, what am I speaking? Remember, if greater than, then you must these are the only cases we can have, right? It's either equal to, less than, greater than, or between. So we've got equal to, less than, between, or greater than. That's all there is. And oh, let me have you punch these in and tell me what you get. Did you get 0.2626 on that one? And then, oh, I don't think I wrote down the last one. Somewhere I did. Yes. If something says times e to the negative fourth, what do you have to do with the decimal? 1, 2, 3, 4, right? E to the negative fourth means you got to scoot it over. And if we round it to the thousandths place, what would this round up to? 0.001. Delta Math will ask you to round to the thousandths place. So basically, if you get a number 3.7 times 10 to the negative fourth, if it's 4 point something and less, it's going to be 0, right? And if it's 5 point something or greater to the negative fourth, then it's going to be 0.001. Very small. Always look at the context of the problem. The probability of getting 5 or 6 winners is very, very low, right? It's very low. So it should make sense. Okay, is that okay? Take time to write yourself a note, right? If you want greater than, you have to adjust. Here I wanted, and I want you to put your little numbers down like this. If it was in the 80s or 90s, you could just do, 90 to 100. But if you put your little numbers down, it will really keep you from goofing up. I can't tell you how many times people will type it in wrong if they don't think. After you do a few, you'll be able to picture that in your head. The homework is just in Delta Math, and it's very short.
Does it matter how many decimal places you round to?
It will tell you in your program, it'll tell you how many decimals to round to. Okay, let's look at one tiny thing. What is a histogram of a binomial distribution? Well, it looks pretty much like a normal curve. But I wanted to go back and remind you of what this looks like. We always picture a curve. I want to tie a big concept here. So skewed left, which one of these graphs is skewed left? B. Which one is skewed right? Which one is symmetric? C. What does it mean to you if a graph is skewed right? What would you say about the graph? If it's skewed right, like A, what does that mean? It means the mean is greater than the median. This is old stuff that we learned, but I want to tie it in because a binomial distribution will be approximately normal. Skewed left means what? Mean is less than the median. Symmetric means mean what? Equals the median. And we want to know this because we really want the big picture. Let's say that the class average on a test was 90. But Grogu here came in and he hasn't been taking notes and he made a 20. Okay, most kids make a 90, Grogu makes a 20. Is that going to change my median? No, the middle will still be 90, right? But is it going to change the average? Yes, he's gonna pull it to the left because his grade is so bad, right? So it's really important to look at that. If you look at house pricing here, what's the average price? Okay, gentlemen, I want you to look up the average price of a home here in our town. Ladies, I want you to look up the median price of a home here. Just go on to Google. Go on to Google and tell me the average home price here. And ladies, tell me the median home price. It'll be in Google. What's average? We just looked it up last block. Anybody find it? Did y'all find the average home price here?
Is it 823,000? Is that right? Or am I looking at something else?
Was that average or is that for median?
That was for average price.
When we looked it up last block, we got 988.
Oh, maybe.
But I don't know. This is just off Google. It could be wrong. Let's say it's 988. When we looked at median, it was 853. Right? So what does that tell you if the median home price is less than the average home price in our community? Why would that be? Yes. In our community, we have several homes that may be well over $1 million, right? They're going to pull the average up. They're going to skew it. Does that make sense? Just trying to get in with what this all means and what these distributions look like. Okay, then I am going to sign off from notes. Your homework is in